Good afternoon, everybody. This is Jeff from Rust Bucket Valley. Welcome to part 3 of Engines 101. This right here will be the final segment and tell you a lot of information about engines. I've already told you some history in the beginning and how the different engines evolved. And this right here is kind of the latest and greatest right here. This is an Asian engine. They have Japanese engines, they have Korean engines. This one happens to be Hyundai engine. It is a 4-cylinder overhead cam 2.4 liter internal combustion engine. You are looking at the front of the engine right here with the big timing chain cover right here, and you'll see why it's so big here in a minute. Funny thing about this engine, this is considered the front of the engine, but it is actually the side of the engine because the engines in a lot of the Asian cars are mounted across the front versus front to back like the regular conventional engines. You'll see the exhaust manifold on here with the catalytic converter with the oxygen sensor. This is called the upstream oxygen sensor. This has a direct feedback to the engine control module. It checks the air-fuel mixture coming out of the engine. And there is another oxygen sensor. It's called the downstream. This is the upstream. Generally, engines have two of them, one upstream, one downstream. They have 4 wires in the connector, and the reason they have 4 wires is because there is a heater that is inside the oxygen sensor. The reason they have a heater in the oxygen sensor is because the oxygen sensor has to come up to about 180 degrees to function properly, and sometimes the heater goes out in the oxygen sensors, and that is one of the trouble codes you will get that will turn on your check engine light. It's easy to diagnose. You just basically look at the amount of current that the heater is drawing using your scan tool, and it will tell you whether the heater is operating properly or not. Okay, we have the timing chain cover. I'll cover that in a minute. Here you have the intake manifold with all the vacuum retard mechanism on it. Right here, there is a hole right here, and there is no carburetor on this engine, and I'll show you why that is in a second. This device right here is called a throttle body. All it does is it takes and allows air. It allows air to come into the engine, and this one here is electronically controlled, so that means there is a resistance switch underneath the accelerator pedal, and there are wires that go to the engine control module, and then from the engine control module there is a connector right here that will give you input to this device. There's a little motor on the side here that opens and closes the butterfly. They'll open the butterfly valve and allow more air to take and go into the engine, and that'll be through this assembly right here. It distributes. You have 4 horns on it, 1, 2, 3, 4. This is 4 cylinders. I'm going to remove this, and you will see where the fuel comes from. So these right here are the ports that go directly into the cylinder head. So you have the induction system, which is the air intake in your car, in the very front. It will take and go through the airbox that has a filter in it. There will be a hose that will take and go from there through the mass airflow sensor, which is another feedback mechanism for the engine control module. Lets the engine know about the air supply. That's the reason that when the hose comes off, or you get a hole in the hose that feeds that system, you will get a code on the engine control module. Turn the mill light on. This right here is the fuel rail. Okay, right here. This has a sensor on it that will tell the engine control module how much fuel pressure there is in this fuel rail. This one right here, I don't see too many of these. However, this one right here is a very high pressure fuel rail. Okay, there is a connector in here, and there's a solid piece of pipe that goes to this unit right here, which is a hyperfuel pump. Okay, this is fed by the fuel pump that is in the gas tank, and you generally get about 35 to 50 pounds of pressure from that. And then this one right here puts it up to about 700 pounds per square inch, and then comes out of here and goes to your fuel injectors. Okay, so obviously some kind of performance improvement. On these Asian engines, there is no one thing that you can take and put on here that will take it from 200 horsepower to 1,000 horsepower. It just does not exist. Okay? Generally what they do is they add a multiple of things, and they will take and get 20 or 30 horsepower out of this. They'll get 10 horsepower out of that, or 25 horsepower out of this. One thing that is very popular on these type of engines is on the exhaust, they will put something called a turbocharger. Okay, a turbocharger is a device that is run by the exhaust gas, and it's kind of like a turbine inside a turbine. One side of the turbine is run by the exhaust gas going into it and out of it, and then out of the exhaust pipe, and then the other side of the turbine comes from a cold air intake, and then it goes around to the other side to the air intake. Okay. And what it tries to do is it tries to take and stuff as much fuel-air mixture inside your cylinder as it can, and then when the spark plug fires off, big explosion, a lot of power, send the piston down really, really hard. Okay, let's take the valve cover off, and I'll show you what's inside there. Okay, so here in the top of the engine, when you take the valve cover off, you will see this is a twin cam. One cam for the exhaust, which is this one right here, one for the intake, and this is a timing chain that keeps everything synchronized. If you take the timing chain cover off, you will see that there are all kinds of guides and stuff that usually go in here. I've removed them for simplicity. It runs off of the crankshaft, so it keeps everything synchronized. You notice an additional chain that goes down here at the bottom, which will go to the massive oil pump that sits down in the pan. Okay. So one of the ways that they make these engines a little bit faster is they do things with the cams. Okay, and this is a cam and this is a cam. Okay, and you'll see that there are like lobes on here, and what these do is they open and close the valves. Whenever you have an internal combustion engine, I would say 99% of the internal combustion engines that are in vehicles, except the electric cars, and we won't even talk about them because we don't talk about them, are 4-cycle engines. Okay, so the 4 cycles that they are talking about have all to do with the valve timing. Okay, so what you're going to do is you're going to have the intake cam come around. You're going to have to hold the intake valve open. You're going to take and load the cylinder with a mixture of fuel and air, and then you are going to close that valve, and meanwhile the exhaust valve will be closed as well. Okay, so that means the engine's running, that means the pistons are going up and down, and the piston is going to be coming up, which is driven by the crankshaft, and it is going to be squeezing that air-fuel mixture that is contained inside the cylinder. Okay, from when the cylinder is empty and the piston is all the way down at the bottom, and then the crank turns around and it drives the piston up to the top. Okay, that volume is called the compression ratio. Okay, if you take 8 volumes and you put it into 1 volume, that is an 8-to-1 compression ratio. If you take 10 volumes and put it into 1 volume, that is a 10-to-1 compression ratio. So there is an engineer whose name is Eddie Iskandarian, and from what I hear, he's still around. He's about 100 years old. Very, very smart guy. What he decided to do is try and see if he can take and create a cam that will keep both the intake and exhaust valve open at the same time after the spark plug has. And what that does is it makes a scavenging effect in the cylinder, and it also leaves some of the burned oxygen fuel mixture in the cylinder, and then the next cycle burns it again. So they call that the Iskandarian 5th cycle. Okay, it's kind of an obscure fact. Thought you might appreciate it. Yeah, it's just something nice to know. Okay, let me take and remove the 2 cams and the cam chain and all this mess, and I will show you the cylinder head. Okay, so I've removed the cylinder head, and if you look at each cylinder here, you have 4 valves to each cylinder. So there you go. The reason they do that is for more efficiency, get a little bit more performance out of it. Again, the intake valves are bigger than the exhaust valves. Okay, intake, exhaust, and your cam actually runs both valves at the same time. This right here is a zero clearance engine. What it means is that if the cam chain breaks and the engine turns around and the piston comes all the way up to the top of the bore, okay, and the valve is hanging open, it will whack the valve and break it, okay, and it will destroy the engine for you. So that's the reason that the timing chains, timing belts, whatever, are suggested to be repaired about every 80,000 miles or so, because they get stretched out and they start jumping time, and you know, the thing starts running badly and all that. On the other engines I've showed you, where they have the cooling passages, they have the bolt holes, very, very common in the engines. One thing odd about this engine that is very, very common among Asian engines is this entire engine is made of aluminum. The one major problem with this engine is that you have to be cognizant of what kind of coolant you run inside this engine, because there are some coolants that do not like aluminum. It will eat it. So you have to use the right type of coolant in there. And here we have the cooling jackets for each cylinder. Another way that they get more horsepower out is they thin this out, they bore it out a little bit. These right here are what's called standard bore. Okay, they're whatever they are, came from the factory. What they will do is they will take and bore these out, so they are very thin. You can go too much, and then you start having overheating problems, but you can get a little bit more horsepower out of them if you take and bore these out, put bigger pistons in there. So that's another way that you can possibly enhance the performance of your engine. Let me set the cylinder head on top of the engine, and I want to show you something. Okay, if you take a look right here, this is one of the intake ports. And let me turn the light up here so you can see down inside there. No, which isn't very good. Okay, but kind of that stick that is that you can see in there, that's all grimy and everything, that is a valve. What they do is they take these chambers and they enlarge them, and they also polish them. This is called porting and polishing. What they want to do is they want to make the largest passage that they possibly can for air-fuel mixture. But porting and polishing has been around for an awful long time. It gives you a couple more horsepower, but you have to send it to the machine shop and get it done. Okay, so let me take and show you the underside of the block. So this right here is the underside of the engine. Kia uses a 3-part engine assembly. They use the cylinder head, which you just saw. This is the main engine block, and then they use like a subsection, and then below that massive oil pump is sitting in the oil pan. Okay, you can see the oil pan sitting underneath there. Another way that they can get a little bit more horsepower out of the engines is they will mess with the position of the pistons. You know, where they are in the cycle of firing, and that will take and give them a little bit more horsepower that way. So you remember a couple minutes ago I was telling you about compression ratio. Compression ratio is how hard the squeeze is on the air-fuel mixture inside the cylinder. Okay? You have to be careful with that. The reason you have to be careful with that is because here's one of the pistons. Okay? And so you have your piston and your connecting rod. Okay, so what will happen if you have a turbocharger on an engine you must take and make adjustments to the compression ratio. Okay, because if your compression ratio is too high and you have too much air fuel mixture inside the cylinder, it will actually take and bend this connecting rod right here, or it will take and break the piston. Okay, so let me show you the bottom of the engine, and then I have one more subject. Anyway, this is the bottom of the engine. So when you take the oil pan off, you will be checking for metal flecks in here, almost like panning for gold. There's a little bit of stuff in here. You see right here, there's some stuff where the bearings were destroyed. So kind of yucky, a little bit sludged up and everything. Then you get the massive oil pump on here, sucking all that up, running it through the engine. Really don't want that to happen. And here is the massive oil pump that's on here. This thing is like 7 times as big as a regular one. So you need a lot of oil flow in these aluminum engines. Keep them nice and cool. Got to keep them clean, keep your oil changed. Change my oil about every 3,500 miles. So change filter too. So it keeps the thing going for a long time. Unfortunately, this one did not have regular maintenance. Got 113,000 miles on it, and it went kaput. So just wanted to take a final look at the 302 engine here. It's one thing that I'd like to tell you about this. There was a guy, he was born in 1888, his name was Fred Offenhauser, and he was a premier engineer who really liked to work on cars, and he started building engines, and he made induction systems. Okay, induction systems are the manifold, which is down in here, and the carburetor. So you have probably heard of Fred Offenhauser, and you've probably also seen his work. When you see any car on the drag strip, and there is this monstrous block of aluminum with all kind of pipes and stuff on it, and it's got a big belt on the front of it that's run off the crankshaft, that is called a supercharger. Supercharger Supercharger does the same thing as a turbocharger. However, the one is run off of the exhaust, and the supercharger is run off the horsepower of the engine. And the main thing that you want to do is get more air fuel into the cylinder and get it compressed as tight as you can, so when you get that spark from the spark plug, it will really send you down the highway, you know, just hundreds of horsepower, if not over 1,000 horsepower. Okay, so I hope that this series has been helpful in answering your questions. Please leave me comments. I will respond. Please like and notify, subscribe. You know what to do. And you will find out when I post a new comment. Thank you so much for following along with this. And hopefully I answered a bunch of questions. And I hope you have a wonderful day. And I'll talk to you next time.